Hi and welcome back to Guardian XOC. Today we're getting right to the point and doing a full reveal of my new CPU pot. We're going to start with how I made it, sort of. This video isn't meant to be a DIY guide, and I'll get to the why of that no DIY later, but I do want to go over the different steps of construction to clarify what I'm actually using for all my sub-ambient overclocking right now. Just as with the Baron Mark II, I planned on making a solid core for the pot and solder into one end of a 2.5 inch diameter copper pipe. Unlike the Mark II though, this core was going to be solid copper, a metal that's actually useful for thermal transfer. This leads me to my first challenge. How do I make a solid cylinder of copper? To make the cylinder of brass for the Mark II, I had to cast it myself from scrap brass that I had available to me. In the end, I did the same for the copper core, but it's much more difficult. Trying to melt copper requires much higher heat than brass, and it took me about 5 different attempts before I could actually cast copper into a mold successfully. And even with the success, the quality was kind of horrid. But horrid works. After much work with a hacksaw and an angle grinder, I turned the rough casting into something that looked more like a cylinder with a smooth top and a flatter cold plate. It looks much better this way and can actually fit into the pipe to the required depth, but it did also reveal the sins of the casting. By sins, I'm referring to the obvious voids in the metal, not that this was stopping me at all at this point. The next step, or next 2 steps, was to drill out holes at the top of the core for increased surface area and soldering it into the pipe's end with a propane torch, and of course solder. That leads it to an almost finished product, except that it has no way to be mounted to a motherboard yet. To provide a mountable surface, I needed a ridge near the base that a mounting plate could sit on. I would have preferred to use a copper coupling that's actually meant for a 2.5 inch pipe, but I couldn't find one at a reasonable price at the time, which left me to a more primitive solution. I took a short length PVC pipe, cut it down to length, put another cut down the length of it, and epoxied that near the bottom of the pot. This left a huge ugly gap, which I know, this would be fully covered by insulation when I use it, and I heavily doubt that it affects the mounting pressure at all. But it bothered me, so I filled it in with several layers of more epoxy and JB Weld, which could be smoothed out with a file at a later time. After a quick paint job, we finally have it. I do want to quickly touch on the performance of the new pot, but as of writing this script, I have only tested it on 2 CPUs on an X58 platform. The first one was a classic i7-920, which I was testing for cheap-ass chips, and a Xeon W3680, which actually has an unlocked multiplier. Both of these chips pull a lot of power, and even though thermal transfer seemed good, I don't think dry ice on this pot was fast enough to really keep up with it, and the temperature kept climbing pretty quickly. Though that may also just be from not having enough surface area inside the pot. I also didn't record any footage when benching the Xeon, but here's a screenshot of the gold trophy score I got for R15. Since this is my first fully copper pot, I would really like to test it on liquid nitrogen, but unfortunately the lowest price I've been able to find locally is almost $4 a liter, whereas I can buy dry ice for just $1.30 a pound, which is much more benching time per dollar. Now you're probably wondering why I haven't shown any footage of the actual process I took for each step of the construction, and there's a couple reasons for that. Firstly, I never intended for this to be a straight up guide video where you could just copy my steps for the same result. I would hope that this gives an idea as to how it can be done, and if someone watched this video and wanted to repeat it, there would be individuals who already know how to use the tools involved with a high degree of safety. I don't consider myself someone qualified to teach people how to do metal casting or use power tools. That, as well as my setup for most of these steps, did work and weren't inherently dangerous, but I didn't exactly do them in a way that I would highly recommend to other people. So a bit of a disclaimer here. If this inspired you to build a similar CPU pot, good for you. Make sure to learn proper workshop safety beforehand. As I have said, this is my first CPU pot that's solid copper and is a huge improvement over what I was using up to this point. I've already made a separate video about the Barons Mark I and II, but what I had been using before the Mark III was another aluminum CPU pot that was much lighter and looked like shit. It also was heavily limited by CPU size as its mass was just under 1.5 kilograms. In contrast, the Baron Mark III has much more surface area to work with and comes in at a whopping 2.5 kilograms. And that is about it for this video. Sorry it took so long to get around to. Despite being summer, my time has proven to be a bit more constrained than expected during the times that I would normally be benching or testing, but I do still have more content in mind, and I'm thinking of going on a productivity bender either this week or next for this channel as well as my other channel, so that way I'll have videos backlogged for the rest of July and August. Hopefully I don't regret that decision.